fractions do not have like denominators. It's Mr. Callan here to help you with Chapter 6, Lesson 7, adding and subtracting fractions with unlike denominators. So let's go ahead, whatever the assignment number was. If you had to do page 167, check your answers. Come on back when you are ready. Of course, we'd love to discuss number 51 in class, but if you have any questions, just let me know. Folks, we're going to take everything we know about equivalent fractions, about reducing fractions, and now we're going to add. Now, we've already done like denominators, so perhaps not surprising. What do we do when we have unlike denominators? And yes, it will be cranking up a notch when you get toward Algebra 1. But that's what we're focused on today, no matter what the date is, no matter what the assignment number is. Go ahead and pause, write down the numbers, the page, the assignment title. Come on back when you're ready. All right, here's something that I have seen many years of my teaching career. 1/3 and 2/4. Oh, let's just go ahead and add horizontally. 3 plus 4 is 7, and 1 plus 2 is 3. And sure, Mr. Callan, the only problem is what looks wrong here. 1/3 and 2/4 doesn't look nearly the same size as 3/7. So let's go ahead and do it right. Now you might say, speaking of same size, I wonder, could we make these all be the same size? And if you guessed, it would appear that 12ths would be an appropriate common denominator. Now if you looked, the orange 1/3 is the same as saying 4/12. Don't believe me? Write it out. 3 times 4 is 12. 1 times 4 is 12. Meanwhile, the yellow 2/4, 1, 2, 3, 4, 5, 6, that's not surprising, is it? It's a half. But ladies and gents, now we're going to be in good shape. Now that they're all the same slices, just put all the slices together. And while that's a good answer, it's not a great answer. It can, of course, reduce by 2 to make 5, 6. So what we noticed is the obvious piece. You must have the same size piece. You must have common denominators if you are going to add two fractions or subtract for that matter. And if you look, you will see, yes, in fact, 1/3 and 2/4 does appear to be the same amount of pizza as 5, 6. That's our focus for today, ladies and gents. I'll go ahead and do number 1 with you. 5/12, 1/3. Now, I know many folks would argue, hey, Mr. Callan, can we do 36? The answer is yes, but I wouldn't recommend it. Perhaps you would notice that 12, 2 times 2 times 3, and 3 have a common factor, which you would write only once with every remaining factor. And yeah, folks, some of you already noticed that 12 was the least common denominator. Now, the nice part there is that 5/12 does not change, but please, 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 please do not tell me that 1/3 is the same as 1/12. 1/3 of a pizza is a decent amount. 1/12, that's barely anything. On the other hand, you could make an argument that 1/3 is the same as 4/12. Now we have 5/12, we can take away 4/12, and we can have 1/12 for our final answer. Onward with example 2. If you wish, pause the video, come on back when you're ready. Common denominator here, the least common denominator would be 20. One could argue that 3/5 is the same as 12/20. And 3/4 would be the same as 15/20. If you don't believe me, 4 times 5 is 20, 3 times 5 is 15. Now, if we were to subtract, ladies and gents, 12 subtract 15, you know Mr. Callan, he likes to change subtraction into adding the opposite. And yes, it is possible to have a portion of a foot below water. Some people would even write the negative out in the front, which is kind of my preference personally, but those are representing the same amounts, negative or the opposite of 3/20. All right, now let's get to the big fellas. So we look at a over 5 subtract c over 10. And if we were looking for a common denominator, perhaps not surprisingly, we would notice that 10 would be the least common denominator. C over 10 does not need to change, but the first fraction will. In fact, while 2 times 5 is 10, we need to be fair to the numerator. So, I know I'm repeating myself here, but as we've talked over and over and over again, a over 5 is the same as 2a over 10. That's the same quantity, it's just cut up into different size slices or represented in another way. All right, but the whole point of doing this is now that we have tenths, we can subtract our numerators. And can we in fact combine those? Well, no. No, we cannot. You see, two A's and a negative or opposite of C are not, I should have put those separate. I don't want to make those look like they're adding. Two A's and the opposite of C, there's no zero pairs. They're different variables. So you can't put those together. They are not like terms. Can anything divide or reduce? Now, I almost said 2 goes into both, but while 2 goes into 2A and 2 goes into 10, we have no way of knowing if 2 goes into C because we don't know what it is. So ladies and gents, that is our final answer. Now, I'd like to do that same problem. Let's say a student did not notice that 10 was the least common denominator. I have many students, in fact, that try to simply multiply the two denominators and use that. Okay, so let me go ahead and show you what happens when you do that. If we were to multiply 5 times 10 and a times 10, we would have a new numerator of 10a all over 50. If we were to multiply 10 times 5 and c times 5, notice I will put the coefficient in front of the denominator. That's just the best way to write it. And now that I have a common denominator of 50, I can go ahead and subtract 10a minus 5c. Once again, you'll notice if I look at that numerator, we have a's, we have c's. They are not like terms. They cannot be reduced. But in this particular case, I'm looking at each of those terms, and I notice they do share a common denominator or a common factor. And so I would have to divide everything by 5. For instance, 50 divided by 5 leaves a new denominator of 10. 10a's split up into 5 parts would be 2a's in each. And the opposite or negative or subtracting c's split up 5c's split up into 5 parts would be a single c. You don't have to write the 1. That, ladies and gents, is the same answer. So while you don't necessarily need to use the least common denominator, my suggestion, always do so, because if not, and of course this is best practice anyways, you always want to look at something to see, can anything in fact be reduced? If we look at that with a bigger denominator, we should have spotted that 5 is a common factor and therefore can be reduced. But using the least common denominator can save us. I'm not going to say it is never reducible, but oftentimes it's already in simplest form. All right, so I wanted to show you that in black, but if you want to ignore it, please feel free. Let's do one more example, example number 4. If I look at 8 and 4 and 6, I know some of you want to say 48, but I happen to notice that 24 is a lesser denominator. So 8 times 3 and 5 W's times 3 would leave us with 15 W's. 6 times 4 and x times 4, of course, I'll rewrite that with the 4 in front of the x. Now that they have common denominators, we can add 15 w's to 4 x's. Are those like terms? No, sir, no, ma'am. Those are not like terms. One has a w variable, while the other is an x variable, so you cannot put those together. Is there anything that divides or reduces? Now, you might have looked at the 4 and the 24, but 4 does not go into 15. That doesn't work. Or you might have spotted, say, a 3, and while 3 goes into 24 and 15, it does not go into 4x's. So in fact, ladies and gents, we already have our final answer in simplest form. If we were to add those two algebraic fractions, finding a common denominator first, we would end up with 15w plus 4x all over 24. So if you need to, go on back, rewind the video, watch it again, try to do problems 22 and 48. first if you wish. Otherwise, you can just head into page 169. Evens are not really too helpful with checking your answers in the back. So if you're getting stuck, go ahead and pick a few odd problems. Check them in the back of the book, and then go back to the evens. Hope that helps, folks. Take care, do well, and let's grow.